You probably think the anaconda is the biggest snake to ever exist. It isn't close, not even in the same category. The largest snake to ever live was so big, it didn't just eat crocodiles, it outcompeted them for the top of the food chain. And it wasn't in some distant alien world. It was right here on Earth, 60 million years ago. Its name was Titanoboa. And once you understand how big it actually was, you'll never look at a snake the same way again. In 2002, a team of paleontologists was digging through an open-pit coal mine in northern Colombia, in a region called Cerrejón. They weren't looking for snakes. They were mapping ancient plant life, trying to understand what the tropics looked like right after the extinction of the dinosaurs. But buried in that coal, they kept finding vertebrae, not one or two, dozens of them. And they were enormous, each one wider than a human hand. At first, some scientists assumed the bones belonged to a large dinosaur that had somehow survived the extinction. But dinosaurs were gone. What they were actually looking at was something almost harder to believe: a snake. A snake so large that its backbone alone looked like it belonged to something else entirely. It took years of careful comparison before the team, led by paleontologist Jonathan Bloch, felt confident enough to publish their conclusion in 2009. The vertebrae belonged to a completely new species. They named it Titanoboa cerrigonensis. And once they modeled its full size using the width of those vertebrae, the number they landed on was almost hard to say out loud. 42 feet long, over 2,500 pounds, a body wide enough that an adult human could barely wrap both arms around it. For comparison, the largest anaconda ever reliably measured today tops out around 20 feet. Titanoboa was more than double that. It wasn't just bigger than modern snakes, it was operating in an entirely different size class. So the question becomes obvious: how does something get that big? And why doesn't anything like it exist anymore? To answer that, we have to go back to what the world actually looked like 60 million years ago. This was the Paleocene epoch, just a few million years after the asteroid that wiped out the dinosaurs. With the giant reptiles gone, ecosystems were rebuilding themselves from scratch. And in northern South America, that meant enormous, humid, swampy rainforests, hot, wet, and absolutely packed with life. Titanoboa lived in these swamps. Fossil evidence places it in river systems and wetlands, spending much of its life in the water, the same way modern anacondas do today. And it wasn't alone at the top. This was not an empty ecosystem waiting for a single ruler. It was crowded with competitors, and Titanoboa beat every one of them. Alongside its remains, researchers found the bones of ancient crocodile relatives called dirosaurids, some stretching over 10 feet long themselves. There were giant turtles with shells the size of dinner tables. There were enormous freshwater fish that would dwarf anything swimming in the Amazon today. On paper, this should have been a battle for dominance. But the bite marks and bone damage found near Titanoboa's remains tell a different story. Instead of competing with the crocodilians for food, Titanoboa was hunting them. Think about that for a moment. Crocodilians are usually apex predators. Nothing eats them. But in this ecosystem, something did. And unlike a crocodile's bite and drown strategy, Titanoboa likely killed the way its modern relatives do. It would ambush prey near the water's edge, wrap its enormous body around it, and constrict. With a body that size, the sheer force involved wasn't something a dirosaurid could fight its way out of. It didn't need speed. It didn't need venom. It just needed mass. Now here's where the science gets genuinely strange. Snakes are ectotherms, cold-blooded animals that rely on outside heat instead of generating their own. And there is a well-documented relationship between an ectotherm's environment and how large its body can grow. The hotter and more stable the climate, the more energy is available, and the bigger cold-blooded animals are able to get. Researchers used Titanoboa's size to work backward and estimate the temperature of its environment. Based on the metabolic requirements a snake that size would need just to survive, the math pointed to something remarkable. The tropics of the Paleocene had to have averaged somewhere around 30 to 34 degrees Celsius, noticeably hotter than the tropics of today. In other words, Titanoboa wasn't just a giant snake living in a hot place by coincidence. Its very existence became a kind of thermometer, a fossil-shaped clue that told scientists something about the entire planet's climate, millions of years after the fact. For roughly 10 million years, Titanoboa ruled that ecosystem with almost nothing standing in its way. No predator was large enough to challenge it. It simply grew, hunted, and dominated the wetlands of what is now Colombia, generation after generation. And then, as the planet's climate slowly cooled, something else happened. The very thing that had allowed Titanoboa to exist began working against it. As global temperatures dropped over the following millions of years, that same size-to-climate relationship worked in reverse. The tropics weren't hot enough anymore to sustain an ectotherm that massive. But climate isn't the whole story of why nothing has matched it since. There's a second limit at play, one that has nothing to do with temperature. As a snake's body gets larger, its lungs and circulatory system have to work harder to push oxygen through a longer, heavier body. At a certain size, that system starts to strain against its own physical limits. Titanoboa was pushing right up against that ceiling. To get any bigger, evolution would have needed to solve a problem that no snake since has been able to solve, in a climate that no longer even offers the chance to try. Titanoboa's line eventually disappeared, leaving only its vertebrae buried in a coal mine for 60 million years, waiting to be found. Today, the largest snakes on Earth, the green anaconda, the reticulated python, are formidable animals in their own right. But next to Titanoboa, they would look almost ordinary, small even. So the next time someone brings up the biggest snake in the world, you'll know the real answer isn't swimming in any river today. It's sitting in a museum drawer in Colombia, in the shape of a single vertebra wider than your hand, quietly reminding us that the scariest things this planet has ever produced didn't need fangs or venom or speed. Sometimes, all it took was size, heat, and time.